Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics 5054. And today we have set our heart to solve ATP paper. We call it Alternative to Practical. And for this purpose, we have selected May-June 2010 4-1 paper. This paper 4 belongs from the Zone 1. The time allowed for this paper is 1 hour. So let's start. In this video, I'm going to present to you the solution of this paper. So here we go. So, here we have the paper. This is, okay. So here we have this paper. May, June 2010, 4-1 paper, the time allowed 1 hour. And let's start today's paper. He says, a student performs an experiment to find a value for the specific latent heat of vaporization of water. An electric kettle, half filled with the water, is placed on a top pan balance as shown in the figure. So here we have an electric kettle, which is connected with electricity, and the water is boiling. And this is placed on a top pan balance, it's electronic balance, and it is telling you what is the mass of this whole thing. Okay, then he says the kettle is switched on with the lid open. When the water is boiling steadily, a stopwatch is started and the reading on the top pan balance is recorded. The total mass M, the capital M represents the total mass of the kettle and the water, is measured every 60 seconds. The readings are recorded in the table figure 1.2. The mass at the start is 1460 and the mass lost. The small m here represents the mass which has been lost. So at the start it is 0. Then we have 1410 gram, and from 1460 minus this thing, you will get 50. From 1359 is the mass at 120 seconds. And from 1460 gram, subtract this mass, you will get 101 gram, which means the mass which has converted into the steam, or the mass of the water which has been lost. So in this way, you from 1460 subtract 1308, from 1460 subtract 1258, from 1460 subtract 1208, from 1460 subtract 157, and you will get the mass which is lost. Okay, so it says the column for the total loss in the mass, which is represented with the small m of the water, is also shown in the figure 1.2. Complete this column. So they want us to complete this column. Okay, this is figure 1.2. I have done this, and let me show you. So it will be 152 grams. This will be 202 grams. This will be 252 grams. And this will be 303 grams. From this mass, I subtract this mass. Then from this mass, I subtract this mass. From 1460, subtract 1208. From 1460, subtract 1157 grams. You will get these numbers. So this is the mass which has been converted or which has been lost. Okay. So here we have the marking scheme, and you can see our answers are right. Okay. Then we have B part. On the figure 1.3, plot a graph of M, the mass which was lost, small m, in grams on the y-axis against the t in seconds on the x-axis. Draw the line of the best fit. Okay, so this graph is starting from the 0, 0. And on the x-axis, we will take the time. On the y-axis, we will take the value of the small m, which means the mass which is lost. And that was the third column in that table. So this is the table. So, you know, the time is going from 0 to 360 seconds, and the mass loss, that is going to 303 grams from 0. So on your, you can see here on the x-axis, we are representing time, which is in seconds. 0, 60, 120, 180, 240, 300, 360. And here we have represented the mass loss that has been represented with the small m. So that is 50, 100, 150, 200, 250, 300, 350 grams. So then what we will do, according to this table, the table which we have, this table, at 0, you will have 0. At 60, this is x-axis, this is y-axis. At 60, you will have 50. At 120, you will have 101. At 180, you will have 152. At 240, you will have 202. And that at 300, you will have 252. At 360, you will have 303. So I will plot these points, and you can see here we have plotted this point, this point, this point, this point, this point, and this point. Then we will draw a line of the best fit. So I hope you understand this. Then he says, describe the relationship between M and the T. We have to describe the relationship between M and the T. And if you look at here, this graph is a straight line. It has a positive gradient, and it is passing from the origin. That means that the mass lost and the time, they are directly proportional to each other. So here is my answer. He says M and T are directly proportional to each other because M and T are directly proportional to each other because the graph is a straight line passing through the origin. So then they say, okay, determine the gradient of the graph, show your working clearly. So what we will do, we will take 2 points on this, any 2 points on this graph. And normally we take those points which are approximately a little away from each other. And we note down their coordinates. And here you go. I've taken 2 points on the graph. One point is 60, 50, and the other point is 360, 300. You know, the formula for the gradient is y2 minus y1 divided by x2 minus x1. This you have studied in your mathematics. And it will be 300 minus 50 in the numerator. And in the denominator, you will have 360 minus 60. So it will be 250 by 300. That is 5 by 6. That is 0.83. So the gradient is 0.83. Then they say the specific latent heat L of the vaporization of the water is given by the relationship L is equals to 2020 divided by the gradient of the graph. So calculate the L, and the units will be joules per gram. So we will simply put the values. So it will be 2020 divided by 0.83. And when you will enter these values in your calculator, you will get 2433.73. So 2433.73 joules per gram. Okay, so so this is the marking scheme, and our answers are right. 2400, they have rounded it off to 2 significant figures. So this can be rounded off to 2 significant figures, and that will be 2400. Okay, so that will be 24. This can be written as 2400 when you round it off to 2 significant figures, joules per gram. Then their question is, he says the mass of the empty kettle is 860 grams. By using your graph or otherwise estimate how long it takes for the start of the timing for the kettle to boil dry. Okay, so the total mass of the kettle and the water was 1460 grams. The empty kettle, its mass is 860 grams. So when you subtract them, you get 600 grams. And that means the 600 gram is the mass of the total water in the kettle. So I can use from my data, 50 grams requires 60 seconds to boil off. So 600 grams will require how much time? This is the method of proportionality. So 50 by 600 will be equal to 60 by T. And the T will be equal to 60 multiplied 600 divided by 50. And that will be 60 into 12, and that's 720 seconds. So it will take 720 seconds. It will take 720 seconds. Then he says, the student is careful not to touch the kettle during the experiment. Suggests 2 reasons why this is sensible. You see this electric kettle. Have a look at this electric kettle. This electric kettle has hot water in it. If you touch it with your hands, bare hands, there are chances that you might burn your hands. Your hands might get hurt. Another reason is because this electric kettle is on that electronic balance. If you will touch it, the reading on the electronic balance, that will change. So these are the 2 main problems I think there are. So it is hot and can burn hand of the student. The kettle is on electric balance and reading on the balance changes on touching it. Then their question is, sorry, I have to go back. Okay, during the experiment, some steam condenses on the lid and the water drips back into the kettle. Explain what effect this has on the value obtained. You see, when the water boils, so you have provided heat and it has boiled off. And when it touches, the steam touches with the lid, some of that steam which come in contact with the lid, that condenses, that converts back into the liquid water, and that water drops again, that condensed water drops again into the kettle. So you have to again boil it. So it means that you will have to now boil that mass of the water which condensed and came back into the kettle again. So your the gradient, the mass of the water which is boiled off, the mass lost, that will take more time on that graph. So the gradient of that graph will be less. When the gradient of that graph will be less, the specific heat, the specific latent heat, that will also be less. Okay, so it will require more heat uh, to to boil off that water. Value of the L increases. The water that drips back into the kettle has to be boiled again. So the gradient of the graph decreases. And when the gradient of the graph will decrease, the value of the L will be more. I can show you. You see the gradient, that the specific latent heat evaporation L, that was 2020 divided by the gradient of the graph. If the gradient of the graph will become smaller, this L value will increase. And why the gradient of the graph will become smaller? You see, it will take longer time to boil off this mass. So this graph will become less steep. Will, its gradient will decrease. When this gradient will decrease, the L value will increase. So these are my answers. So we are done with the question one. Let's have a look at the marking scheme. You can see the marking scheme of the question number 1 that is showing up on your screen. So if you want to read it more carefully, you want more time with this marking scheme, you can pause the video and you can take your time. Okay, so that was the question number 1. So we are going to the next question. That is question number 2. In the question number 2, we have a cyclist, and that cyclist is basically is moving on this circular track. Okay, so here we have a group of students is asked to perform an experiment to take readings to plot a distance time graph for a cyclist. So if you want to draw distance time graph, you need time and distance from a certain place. Okay, so at distance from a reference. Okay, so estimate the time taken for a cyclist to cycle 100 meters. It's a very simple. We have to estimate. You don't have to you don't have to get exactly how much time. It's just you have to estimate that how much time 100 meter if you're cycling. So how much time it will take for a cyclist to cover 100 meter? It might take 20 seconds. It might take 25 seconds. It might give 30 seconds. So it's just 25 seconds. We think it will take 25 seconds. Okay. So I think the answers are right. Okay. Then we have, he says the cyclist will cycle 100 meter around a flat track as shown in the figure 2.1. So this track is actually 100 meter long. Name a suitable measuring instrument to measure the length of the track. The length of this track can be measured easily with the trundle wheel. Trundle wheel. That can be measured with a trundle wheel. The time taken by the cyclist, you can measure the time taken by the cyclist with the help of a stopwatch. And so trundle wheel, and it's a wheel, and you walk with this wheel along the track, and it notes down how much is the length. Then he says the speed of the cyclist will change as she travels around the track. Describe how the students can take readings to plot a distance time graph for the cyclist. Okay, so very simple. On every 10 meter, after every 10 meter, put a mark on the ground. For example, you can put a flag there. You can put a board there on the ground after every 10 meter. We call it fiducial marks on the ground after every 10 meter. When he starts his race, start the stopwatch. When he's on the first fiducial mark, note down what is the time. When he's on the second fiducial mark, note down what is the time. When he is on the third fiducial mark, which means 30 meters, and note down the time. When he's on the fourth fiducial mark, note down the time. And you will have time and distance. Then you can plot a graph between time and distance. Take the distance on the y-axis and time on the x-axis, and then plot those points, and then you will get the, join them, you will get the distance time graph. Put fiducial marks are those marks which are like flag, like a board on the ground, or a mark on the ground. That is called the fiducial marker. Put fiducial mark or marker on every 10-meter distance. Start stopwatch when the cyclist starts, and note time when he crosses each fiducial marker. Draw a graph by taking distance on the y-axis and time on the x-axis. I hope you understand this. So this is this part. I hope you understand. Okay, so this was my answers. Okay, we are going to next question. The cyclist in the B starts from rest and accelerates until he reaches a constant speed. On the figure 2.2, sketch her distance time graph. Label, this thing is very important. He started from the rest and he accelerates. His speed is increasing. And then he starts moving at a constant speed. So here you have to draw a graph. So first the graph will be flat, and then it will accelerate, and then its speed will become constant. You see, after this it will comes. Sorry. Sorry. Oh, sorry. Something has gone wrong. So you see here the gradient, we're talking about this one, okay? Here the gradient is increasing. It's a distance time graph, which means the speed is increasing. And here the distance time graph, it has become a straight line. Here we have tried to show a straight line. That means the gradient has become constant. That means the speed has become constant. Look at this line, okay? Then we have a second cyclist starts from rest, but he accelerates for the first 50 meter and then decelerates for the last 50 meter. He takes the same total time to cycle 100 meter as the first. Okay. So on the figure 2.2, sketch the distance time graph for the second cyclist. Okay. So this is the second cyclist. This graph. Okay. First he accelerates. The gradient of the graph is increasing, and then he decelerates. So the gradient of the graph is decreasing. You see, here the gradient is increasing, which means he's accelerating. Here the gradient is decreasing, which means the speed is gradually decreasing. So, so this is how you do this. Just forget this. This I just by mistake. Okay. So this is the marking scheme of the question number 2. You can pause the video if you want more time with the question number 2. Okay, then we have this question number 3. He says, a student takes two resistors A and B from a drawer labeled 220 ohm. The two resistors have different colored bands as shown in the figure 3.1. Okay, so we know okay. So the first color here is red, the second is red, the third is black. Here red, and brown. Remember, the first color tells you the digit. The second color also gives you the digit. And the third color gives you the multiplier. Okay. For example, red means 2. Okay. The next red also means 2. Okay. The third color is multiplier. Multiplier means 10 raised to power. And the black means 0. So the 10 raised to power 0. You know, 10 raised to power 0 is 1. So 22 into 10, that will be 22 ohm. So the resistance of this resistor A is 22 ohm. If you look at here, the first is the digit, that is 2. The red means a digit. But the second color means the digit. Okay, that is also 2. Okay, multiplier. The third color is multiplier. Multiplier means 10 raised to power. What? That's brown. Brown means 1. So 22 multiplied 10, that will be 220 ohm. 220 ohm. Okay. So we have 220 ohm. So that is the resistance of these wires. Okay, this is state which resistor was in the wrong drawer. So he wrote on the drawer 220 ohm. The resistor A, its resistance is 22 ohm. And the resistor B, its resistance is 220 ohm. So the A is in the wrong drawer. This one is in the right drawer. Okay. So they say state which resistor was in the wrong drawer. That is the resistor A. And show the resistor color code to give the, use the resistor color code to give the resistance of the resistor stated in the first part. So we have calculated that here. You can see. Okay, let me show you my work. I have also done this little work. I've explained you how this is done. And here we go, A and 22 ohm. So this is question number 3, A part. Okay. Now we are going to the question number 3, and it's B part. He says the student takes 5 more resistors from the drawer. The student checks the resistance of each resistor using an ammeter and a voltmeter. In the space below, draw a circuit diagram of the circuit that he uses. So if you want to find out the resistors, you need to know the voltage drop across that resistor, and you need to know the current flowing through that resistor. Divide the voltage with the current, and that will give you the resistance. Okay. So here, you know, this is that resistor. And here I have, for the safety purpose, we have put a variable resistor. Here we have the ammeter, which will tell you how much is the current flowing. Here is the switch, and here's the battery. And here we have, or you can say it's a cell. And here we have put a voltmeter across that resistor. Okay. So this is the famous circuit which is used to measure the resistance of this resistor. Okay, then he says, let me show you the, here we have. Okay, then we have, he says, the measured resistance in ohms of the 5 resistors. Okay, the measured resistance in ohms of the 5 resistors is 218, 220, 219, 223, 221. The student concludes that all 5 resistors were in the correct drawer. Explain why the measured resistances are not all exactly equal to 220. This happens due to the manufacturing. You see, when they manufacture the resistors, so in the manufacturing, there is a little bit difference of resistors. We call it, when the, you see, when the manufacturer provides you the resistors, they write the tolerance of the resistance, of the resistor. Tolerance means that, for example, the tolerance is 5% or the tolerance is 10%. It means the resistance which we are claiming, its actual value might be 5% more or 5% less than our claim. Or if the tolerance is 10%, it means the value of the resistance which we are claiming that this resistor will have, its actual value might be 10% more or 10% less. So this happens due to the processing of the manufacturer, due to the material, or this and that. So manufacturer claims that resistance has 5 to 10% tolerance due to manufacturing. That happens due to the manufacturing. This is due to the tolerance difference in manufacture. Maybe the resistors you have, they are from different manufacturers. So that's why. All resistors are not identical. So that was question number 3. Then we have a question number 4. He says, an experiment is performed to demonstrate the repulsion of like charges. Two identical plastic rods A and B are each rubbed at one end with identical cloths. Rod A is then suspended from a cotton thread so that it can swing freely as shown in the figure. So what they have done, for example, this is the rod A. Its one end has been rubbed with a cloth. And then they have another plastic rod B, and same material, same everything. Its one end is also rubbed with the cloth. So both the plastic rods, the ends which you have rubbed with the cloth, they will get charged and they both will have the same charge. Okay. So their question is on the figure 4.1, draw the position of the rubbed end of the rod B so that the force produced on the rod A is as large as possible. So if you want the force of attraction or repulsion between them to be maximum, so maximum surface area of both the ends where they are charged should be facing each other. So here you can see I have made this. So this end of the rod B has been charged, this end of the rod A has been charged. So place the rod B like this. So now they are maximum surface area facing each other. Okay. So then he says, describe and show on the figure 4.1 the direction in which the rod A will move. Because I think that both the rods will have the same charge, so they will repel each other. So the rod A will swing in this way. So it's like a anti-clockwise manner. So here we have shown, try to show that. Okay. Rubbed ends of the rod A and B and the rod B have same charge. They repel each other. So that's why it will swing anti-clockwise. It will try to move away from the rod B. Okay. And explain why the rods are rubbed with the cloths of the same material. So we rub because both the rods are of the same material and we rub both of them with the same cloth. The reason is that we want them to have the same charge on them. So both rods are of the same material, and when they are rubbed with the same cloth, they will have the same charge on them. Then the question is, the rods are left on a bench for a day after rubbing. Explain why the experiment does not work. Now it does not. The reason is, you see, if you will have a charged rod and you place it on the table and you went away, so because of the moisture in the air, and it will start losing its charge. And after one day, it might become neutral. Rods will slowly lose their charge after one day. They might have lost all their charge. So you cannot do that experiment with them. You have to rub them again with the charge, with the cloth. Okay. So the rod alongside right hand side. So this is here we have the marking scheme for the question number 4. And you can pause the video if you want more time with this marking scheme. And this is my answers. These are my answers. Okay, this is whole question number 4. So we have reached the end of this paper. So thank you very much for taking out time. So, my dear students, today in this video, we have done May-June 2010 Physics 5054 4-1 paper. This was an ATP paper. Alternative to practical, in this video, we have done the solution of this paper. And I've tried my best to explain you the concepts. And I hope it will help you. And if I have made any mistake, just forgive this. And always check my work, your teacher's work, your colleagues' work with the marking scheme. So if you find this video interesting, useful, please share the link of this video with your friends, with your junior students, with your senior students, with your teachers, because when you do this, it helps me to promote my channel. I think it's a great blessing for me that I can make these videos and share with you and makes the students, so many students' life easier. Thank you very much. Have a good day. God bless you all.